Math 2, we're working on word problems involving arc length and area of sector. For today's assignment, you're going to read through word problems. The first thing you'll need to do is decide whether or not you're solving for the area of a sector or the length of an arc, and then use your formulas to calculate what is being asked. So let's talk about a few of these and I'll let you finish the rest. We'll get them started. There's some nice keywords that you can look for up here. I think one of the best parts too is that you can look at the units and make sure that your arc length units are in one-dimensional units and your area of a sector units are square units. For number 1, we're told that Austin has the circular patio shown below. He wants to put brick on the shaded region of his patio. How much brick will he need to cover the patio? Round your answer to the nearest whole number. For this one, we want to use area. We can see that the word shaded is included in our word problem. We're going to try and find the area of this region here. So remember that for either arc length or area of a sector, you're using your circumference or your area formula and then multiplying by the fraction of the whole circle. So for number 1, we're given, we can see in the picture that we have 160 degrees as our central angle, which is the same measure of the arc. We're going to divide that by 360 because that's our entire circle, and then we'll multiply that by the area, which is the radius squared, so 20 feet squared times pi. I'll let you finish the rest. Make sure that your units end up in square feet and that you're rounding to the nearest whole number. So no decimal place, just the nearest ones place. For number 2, Pat has a circular garden in his backyard. He needs to replace a portion of the fencing shown below by the darkened arc. How much fencing material will he need to buy? Round to the nearest hundredth. So just like with the first one, number 3 here, we have the word fencing, which is one of the key words for arc length. So we're going to use our circumference formula and multiply by the fraction of the circle that we're looking at. So the arc length here would be 120 degrees. That's our central angle measure. Divide by 360, which is the full circle. And when we multiply that by the circumference, it's 2 times the radius times pi. Again, make sure that your units are in feet. You're rounding to the nearest hundredth. Remember, the number 100 has 2 zeros, so you'll round to 2 decimal places. And then for number 5, we're told that Jacob ran along the darkened edge of his circular path shown. How much farther would he need to run to complete the circle? So we're not actually finding the distance around the darkened path. We want to know how much more does he have to go. So he's going to run from A to B to finish his lap. So before we do that, we need to know the measure of this central angle here. If he's already run around 315 degrees of the track, we're going to take the full track 360 degrees, subtract that 315 to get 45 degrees. This is circumference, part of the circumference, so we're looking for arc length here. So again, we're going to multiply by the fraction of the circle, the 45 degrees left over that he has to finish, divided by the full circle, and then multiply by the circumference, which is 2 times 12 meters times pi. Your units are going to be in meters. It doesn't tell you to round, so let's round to the nearest tenth. round to the nearest tenth. As the number 10 has 1 0 in it, you're going to round 1 decimal place. Please see me if you have any questions. Make sure you turn in your assignment when you're finished. Have a great day, Math 2.